Hi, this is Don Kost, and I'm the TME for the Valor division of Siemens. In this video, I'm going to discuss some new functionality that was added to the 2504 release of Valor NPI. In this video, I'll be talking about the rigid flex checks that were enhanced to better align with the fabrication process. The biggest enhancement for this version is the improvement to the rigid flex analysis. This analysis is better aligned with the industry standards on required checks, and it also provides enhanced flexibility with the support of several rigid flex related constraint factors. I'll cover these new features now. Here is the list of the improved rigid flex constraints in ADM. There are 11 new constraints that have been added, making rigid flex checking better aligned with the industry standards on required checks. For more detail of the enhancements, you can refer to the Valor NPI 2504 Release Highlights document. All the changes to the existing checks, as well as information for the new checks, can be found there. A new factor called FPC Region Factor was added. This factor considers different regions of the design based on rigid area or flex area. As per fabrication requirements, some constraints require different settings for the rigid area versus the flex area. Each area has unique challenges, so now the constraints can be set differently depending on which area is being checked. The transition area has been replaced with the transition axis. This is where the rigid and the flex areas meet. Using the transition axis simplifies the setup of these checks. The affected constraints are listed on the slide. This area factor is automatically added to these constraints. For example, via spacing constraints may require different spacing to the transition axis in the flex area than in the rigid area. In previous releases, we only supported negative representation of the coverlay layer. The coverlay openings would be displayed as solid shapes, while the actual coverlay would be displayed as a hollow shape. In 2504, we also now support positive representation of the coverlay layer. The coverlay will be displayed as a solid shape representing the material itself, while the openings will be displayed as hollow openings. The analysis is performed based on the polarity set in the matrix and provides correct results without any modifications to the corresponding coverlay checks. Another newly added factor for rigid flex is the stiffener technology factor. Stiffeners can be implemented as different materials: polyimide, FR4, metal, or other. A metal stiffener can be used for grounding or shielding, while the other types of stiffeners would be used to strengthen the board during assembly. Because the different stiffener types may have different constraint values, there is now the option to define the values based on the type. The affected constraints are listed above. The stiffener type is identified based on the subtype of the stiffener layer in the matrix. And finally, a third factor was also added to this version. It is called FPC copper type. The purpose of this factor is to support different values for different copper types: rigid copper or flex copper. This factor can be used with the rigid flex constraints, but it can also be used for the general fabrication constraints like signal analysis and power ground analysis. Rigid or flex copper type is identified by the subtype in the matrix. In the example, when this factor is used for the same plane spacing constraint, there can be different values depending on whether the copper type is rigid or flex. So that's a quick look at the new enhancements for the rigid flex checks that were added for 2504.